Hello, welcome to Learn with Laknani. So, in this tutorial, I'm going to explain the random module of NumPy. So, through the random module also we can create ND arrays. There is a lot of importance is there for random module. With the help of random module, we can create NumPy arrays by creating the random data. This module contains several functions to create ND arrays with random data. So sometimes we need to generate the random data, random arrays, random modules. And sometimes in normal distribution, uniform distribution, you need to generate some random numbers. Through that random numbers, you have so many data, you have so much of data analysis. In such cases, you need random arrays, random numbers. Okay. So how can we generate the random numbers? How can you generate the random arrays with the help of NumPy random module? You can create random numbers, random arrays of any shape. In any shape, you can create the random numbers with the help of Python random module. So in this entire lecture, I will explain all the random module related methods, okay, with hands-on experience. So before going into the content, please subscribe to my channel Learn with Laknani so that you will get more updates from our channel. Please subscribe to our channel Learn with Laknani. Now today we are going to discuss NumPy.random module in Python. The random module is a module present in the NumPy library. This contains several functions which are used for generating the random numbers. This module contains some simple random data generation methods, some permutation methods, some distribution functions, and random generator functions. This module exclusively contains several functions to create ND arrays with random data. So many times you need to generate the random data. So how can you generate the random numbers, random data? So with the help of NumPy, a random module, definitely we can generate the random data. Here I am going to explain the starting method in the random module. So first of all, before writing the random method, first of all, you have to import the NumPy. Import NumPy as NP. Okay, import NumPy as NP. Suppose actually if you want to know the syntax of any method, you can know the syntax of any method with the help of a function called as help. If you write help of np dot random module dot randint. The first method which I am going to explain you is randint. Randint. If you execute this command, then you can know actually the syntax of the randint. This is the syntax of the randint. Okay, method. In the randint, the syntax is here np.random.randint. Here you have to specify from where you have to start. What is the highest value? So low, high, and what is the size? By default, the high is none, and by default the size is none. If you want to specify the size, you can specify the size, and the data type is integer. Okay, so this is the syntax of randint. So with the help of this syntax, we are going to generate the random integer numbers with the help of np.random module. Here you can see the randint syntax as randint low, high is equal to none, size is equal to none, data type is equal to int. That means it returns random integers from low. Low is inclusive. That means from low to high, the high is exclusive. So that means it is represented as closed interval low and open interval high. That means low is inclusive and high is exclusive. So if high is none, the default is, then the result always starts from 0 to low. If we have not mentioned the high, always it will consider from 0 inclusive to low exclusive. So if you mention the high and low value from low inclusive to high exclusive. So this is the syntax of rand int. Suppose if you want to, we will take some example. NP dot. So you have to write the random module. So NP dot random dot. Here I am writing rand int. Suppose if I write rand int of 10, that means here I have not mentioned here I have not mentioned low and high. That means the 10 will be treated as high. So from where it is started? From 0 to 10. So from 0 to 10, it generates a random value that is nothing but 7. Any one single random number will be generated. Suppose if I write np dot random dot rand int of 20. That means what is the meaning of 20? Here from 0 to, if you don't mention low and high, it generates the numbers from it prints any number, random number from 0 to open interval 20. That means 0 to 20. One number will be printed. Any random number will be printed. We cannot guess that number. So because it is random number, suppose if you execute this code, then it printed 17. So 17 is a random number from 0 to 20. Suppose if you press again, then 2 is generated. If you execute again, 12 will be generated. We cannot give guarantee that the same number will be generated again and again, because random module importance is that is the only one. We should not expect the value. So we are getting the OTP. That OTP cannot be expected by any person. So it is a random number generator. Your OTP is a random number generation. So whenever I am executing np.random.randint of 20, it is again and again creating a new random number. Okay. So here I have mentioned only one number in the randint. Suppose if I write np dot random dot rand int of suppose 1 comma 20. So what is the number it is generated? It has generated a number 6. So how the values will be considered? The values will be considered here as from 1 to exclusive of 20. That means 1 is included and 20 is excluded. So from 1 to 20, any one single random number will be generated with random np dot random dot randint. So here 6 is generated. Suppose if you execute this again, we cannot give guarantee. So here 4 is generated. If you run again, so again sometimes 4 is again it has created the 4. Now you got 5. Now you got 30. Now you got 10. So we cannot give guarantee that the same number will be generated again and again. Sometimes same number will be generated. So this is out of our guess. That means it is a random. So any random number will be generated. Okay. So there is another way of using the random number. Suppose if I write np dot random dot rand int np dot random dot rand int. Here I have mentioned 100. Size is equal to 10. Size is equal to 10. Now you can see that means I am trying to generate 10 random numbers from 0 to 100. Here I have mentioned only one value. That is 100. So if you don't mention low and high, so this low will be treated as a high value. That means from 0 to, that means closed interval 0 to open interval 100. What is the meaning of this? 0 is included and 100 is excluded. So 0 is inclusive and 100 is exclusive. From 0 to 100, So 10 random numbers we are going to generate. So 10 random numbers we are interested. 10 random numbers we are generating. 10 random numbers we are generating. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 random numbers it is generated. So random numbers may be repeated again. Okay, here 5 came, again another 5. This is a random. We cannot guess what values will come. We cannot, and also we cannot expect that values shall not be repeated. Any values will be generated in between 0 and 100. Here in this, we have created a one-dimensional array. Suppose if I write np dot random dot rand int 100 comma size is equal to I want to create a random array of integers of size 3 by 5 in which the array element shall be in between 0 to 100. So now you can see, so it has created an array of random numbers from 0 to 100. 100 is exclusive, 0 is inclusive. So these are all 3 by 5 shape array, two-dimensional array is created in which the elements are random numbers. All the numbers are in between 0 to 100. So this is a random data. So where all the elements are integers. All the elements are integers. So this is the way of creating a random integer array of with any random data. If you want to create a three-dimensional data, then you can create the three-dimensional data also. So how you will create the three-dimensional data? If you write np dot random dot rand int. Suppose I want to create 1 comma 200. That means here I have mentioned the low and also high. That means 1 is inclusive and 200 is exclusive. So from 1 to 200, I want to create an ND array of size is equal to 3 comma 4 comma 5. That means I want to create a three-dimensional array. So you can see here it has created a three-dimensional array. So this is a three-dimensional array. As you all know, the three-dimensional array is nothing but a set of two-dimensional array. So this is one two-dimensional array. This is one two-dimensional array. And this is one two-dimensional array. Okay, so it gives a three-dimensional array. So here, this is a three-dimensional array which is consisting of random values, random integers. So what is the range from low to high? From 1 to open interval 200. 1 is inclusive and 200 is exclusive. So if you mention the size means the shape of the array. If you mention only size is equal to some single number, the shape will be a one dimensional. If you mention the size is equal to two elements, two numbers, then it will be a three dimensional. If you mention size is equal to 3 integers, then it will be a three dimensional. Like this, you can create any shape of random array with the help of rand int. It always generates the integer values only in between the given range from low, inclusive low to exclusive high. Suppose here I am writing, you can store this random array, random ND array into some other variable. So here a is equal to np dot random dot rand int of suppose I want to create from 2 to 20. here I am giving the size is equal to I want to create 10 numbers. I want to create 10 numbers. So suppose if you print A, so what happens? It has created 10 numbers from 2 to 20. 2 is included and 20 is not included. In between 2 to 20, it has created 10 random numbers. So if you want to see the type A dot D type, so all the elements are of type integer. Suppose if you want to change the data type of the any ND array, you can change the data type as, suppose if you write like this, B is equal to a dot we have a special function method called as type. So I want to convert the A is an array which is consisting of integer values. Now I want to convert these integer ND array into float type. So in order to convert any array to any other array, we have another method called as type. So B is equal to A dot as type of, so I want to convert the integer array into a float array. Now if we execute B, so you can see that all the elements have successfully converted into integer type to float. So the array which we have created is integer array. Now the array which we got is float array. So what is the function which converts an integer to a float? As type. So from any format, from any data type to another data type, you can convert with the help of a special method available in the NumPy. The method is as type. So A dot as type of float which converts your integer array into float array. So this is the method. So this is the method. A dot as type within the bracket you mention in which format you want, in which data type you want. So it simply converts the elements into that type. Now I am printing B, so I got all the elements are of type float. Suppose if you write B dot D type, so what happens? It is showing that float. Initially you have taken the integers, now we have converted the values into float type. So another method of random module is rand. So here I have already explained what is a rand int. So in the rand int, you can specify the range from where to where you want to clear the random integers. If you don't specify the low range, it will be 0. Okay, but when it comes to the rand, it always generates float values in the range 0 to 1. Here 0 is inclusive, 1 is exclusive. So whatever the shape you want to generate, it may be a 2-dimensional, whatever may be the size, it may be a 1-dimension, it may be a 2-dimension, it may be 3-dimension. Always rand method will generate the float values in between 0 to 1, but 0 is inclusive, 1 is exclusive. That means 0, close interval 0 and open interval 1. So rand is a method. It always generates random float values in the range 0 to 1 from uniform distribution samples. So here 0 means 0 is included, 1 means 1 is not included. So like that it generates the rand method will generate always floating values only, and also the floating values are always between 0 to 1 and 0 is inclusive and 1 is excluded. So you can, if you want to create any shape NumPy array, you can create any shape NumPy array. It may be a 1-dimensional, or it may be a 2-dimensional, or it may be a 3-dimensional, but the elements in that generated NumPy array is random values. All the random values are float values only, which are in between 0 to 1. Suppose if I write like this, np dot random dot rand. Here I have not mentioned anything. Here I have not mentioned anything. Now I am executing this. See, if you don't mention anything, if you don't give either high value or low value, by default, it will generate only a single value, single float value, which is in between 0 to 1. So if you don't mention any high or any low, then it always generates only one single value. It generates single value. That means it generates a single float value in between 0 to 1. Here I have not given any high or low. Here I have not mentioned any size. Here I have not mentioned the size. So here I have simply taken np dot random dot rand. So it simply generates a random float value in between 0 to 1. Here I have not mentioned any size. If you don't mention any size, simply it gives only one value. Suppose if you write like this, np dot random dot ran of 10. That means here I am giving the size. That means I want to create a one-dimensional. If you mention only one value, that means you want to create a one-dimensional array of size 10 elements. All the 10 elements are created from the 0 to 1. All the 10 values are created from 0 to 10. That means 0 to 10 float values, 0 to 1 float values. 10 floating values will be generated in the range 0 to 1. You can see. So, how many values it has generated? It has generated 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 float values. 10 float values in between 0 to 1, closed interval 0 to open interval. So like that, it has created a 10 elements. So here the array type is one-dimensional array. Suppose if you want, here I have not stored the array. So here it is given the one-dimensional array. Suppose if you store this array in some element, in some variable. Now if you want to see, if you want to print A, it will print A. If you want to know the type A dot D type, it is saying that it is a float. Suppose if you once again if you run that, again the values will be changed. Why? Because they are the random numbers. You cannot give the random numbers again will be generated in the same fashion. So whenever you are executing the same statement, the random numbers will be changed. Here you got suppose if you see the first number 0.3947 45 something. Suppose if you execute again, and if you print A, so the numbers are changed because it is random numbers now. You cannot expect the same number again and again. So if you mention a rand of 10, that means the size of the array is 10. Okay. Suppose if I write like this, np dot random dot ran, in that I have written 5, 10. That means here I have given the size. The size is 2-dimensional array. So what is the size of the 2-dimensional array? 4, 5. That means 4, 5 means 20 elements. So 20 elements will be created. 20 numbers will be created. 20 float numbers will be created. So all the float numbers are in between 0 to 1. Suppose if I write this, see here, 4 rows and 5 columns. All are float values. So what is the range of these float values? From 0 to 1. So please remember that the rand method in the random module always creates the floating point numbers only in between 0 to 1, where 0 is inclusive and 1 is exclusive. Suppose if you want to create 3-dimensional array, simply you can write np dot random dot rand some 2, 3, 4. I want to create a 3-dimensional array of size 2, 3, 4. That means random numbers will be generated. So All these are ND-arrays. All these are ND-arrays only. So that means these are the different ways of creating the ND-arrays. So in the previous video also I explained different ways of creating the ND-arrays. Apart from those normal methods, there is a special module, that is random module, in which you have several methods through which you can create different ways of ND-arrays of random data. All are creating with a random data. After the rand method, next method is another similar method is there with a custom low and high. You can give the customized range. So in the random, you are not supposed to give anything. Always the float values will be generated in the range 0 to 1. That means 0 and 1 is fixed. But in uniform, it is also working like a random. But the difference is in uniform method, you can customize your range. That means in uniform, in the range, in the random, the range is always in between 0 to 1. But in the uniform, you can give the customized range. That means you can give your customized range from low to high. But either in the random or uniform, it always creates float values only. Either it may be a uniform or it may be a rand method. It always creates a float values only. The only difference between a rand method and uniform method in the np.random module is rand always gives the values or float values in between the range 0 to 1. So here the 0 to 1 is fixed. When it comes to the uniform, customer has given, that means user has given a chance to customize his own range from low to high. But in this case also, you will always get float numbers only. So that is the only difference between rand and uniform. Suppose if you see how uniform can be used, here np dot uniform np dot random dot uniform. Here I have opened the brackets and closed the brackets. Here I have not given any customized index. So simply I have written np dot random dot uniform. So if you execute it, it prints a value. So in uniform, I said that you can give a customized range from low to high. But here I have not given any low to high. If you don't mention any low to high, always by default it will take the range from 0 to 1. Here 0 is included and 1 is excluded. So in between 0 to 1, it has generated one random number, one floating random number. That means if you don't mention your customized range, it simply acts like a rand. So it is equal to the rand. That means you can say like this. You can say this. It's simply equal to np dot random dot rand. It also creates a single float number in between 0 to 1. It also creates a single float number 0 to 1. Here, even though you have a chance to customize your range, I have not mentioned anything. If you don't mention anything about range high and low, then it will simply takes the range as 0 to 1 and it prints one value in between 0 to 1. Okay. Next, suppose if you write like this, np dot random dot uniform. Here I have mentioned 10, 20. That means here I have mentioned my customized range. Here I have mentioned my customized range. Now that means I want to print one random float value in between 10 to 20. That means 10 is included, 20 is not included. Suppose if you execute this, it has generated a random float number in between 10 to 20. Here I have mentioned the range. Here I have mentioned the range. Here this is low. This is high. That means low is inclusive, high is not inclusive. That means exclusive. That means from 10 to open interval 20, it has generated one random number. It has generated one random number. That is 13 something, 86 something something it has created. Okay, that is your customized in giving low and high. Suppose I want to create 10 random numbers in between 10 to 20. So how will you need to mention the size? np dot random dot uniform. Here I have mentioned I am giving the customized low and customized high. So 10 comma 20 comma, here I am writing size is equal to 10. That means I want to create a one-dimensional array, ND array of size 10, in which the 10 elements are in between 10 to 20. So this method uniform creates 10 random floating values in the given customized range, that is from 10 to 20. So here it has given 10 values, that is the size. So here size is equal to 10 means it is creating only one dimensional array. Suppose if you save this in some method, some variable, now if you print a, it is giving the one dimensional random floating values. Suppose if you want to know the type, if you want to know the dimension, you just write a dot endem. It is a one dimensional. If you want to know the d type, you just write. So you can see all the values are float by default. Rand or uniform will give only floating values. Rand will give you the values in between 0 to 1. Uniform will give the values in between the given customizer range. That means from low to high. So here I have mentioned the size is 10. That means I want to create a one-dimensional array. Suppose if you want to create a two-dimensional array, you can write like this: np dot random dot uniform. So I want to create in between the range 10 to 20. I want to create the size is equal to, I want to create a two-dimensional array of size 3 by 4. So now you can see it has created a two-dimensional array of size 3 by 4 where it takes 12 elements. All the 12 elements are floating point numbers in between 10 to 20, where 10 is included and 20 is not included. Okay, so this is the way of creating a random floating numbers in the given range or in the customized range using uniform. So far we have discussed what is the randint method in the random module, and what is the rand method in the random module, and what is the uniform method in NumPy random module. So in the similar way, another important method is randn. Okay, this is for normal distribution. So if you want to create a normal distribution with mean 0 and variance, that means standard deviation is 1, then you have to use the method randn. So the numpy.random.randn function creates an array of specified shape and fills it with random values as per the standard normal distribution. So it creates an array. How it will create an array? As per the standard normal distribution with mean 0 and variance 1. So in that manner, you can create a randomized data with the help of randn with any shape. You can mention the shape. So it will create a random data which satisfies the standard normal distribution. So that is the purpose of randn. So let us take an example on this. Here A is equal to np dot random dot rand n. Here, if you don't mention anything, here I have not mentioned anything. Suppose if you want to print A, it generates a negative. So you can expect the negative values also. Why? Because the mean is 0, so the deviation is 1. So from 0 to that left hand side and right hand side, any value will be printed. Here it created a negative value, negative float value. Suppose if you want to mention the size, let us suppose A is equal to np dot random dot rand n. Here I have mentioned the size as 10 elements. Okay. Now if you want to print A, you can see here it has generated a one-dimensional array of size 10 elements, in which it has generated 10 random values which consisting of both positive and negative, keeping the point that it is all the values shall satisfy the normal distribution with mean 1 and standard deviation with mean 0 and standard deviation 1. Okay, that means it has created a one-dimensional array with mean 0 and standard deviation 1. Always you have to keep in mind that rand n, it here what happened, it generated one dimensional array with mean 0 and standard deviation 1. So all these 10 numbers are satisfying this condition. So they are all uniform distribution. Suppose here what we are saying, that here it is generating a rand n. That means rand n is generating 10 floating values which is satisfying the mean 0 and deviation 1. Let us suppose whether we are getting mean 0 or not. So let us suppose if you take printf, f, here I am using the f string, f mean is equal to a dot mean. In the similar fashion, I want to print f string variance is equal to a dot var. A dot var here. Okay, a dot var. Next, and also I want to print f string standard variance and standard deviation. I want to print standard deviation is equal to a dot std. The standard deviation method is a dot std. Here this method is rand n method is very useful in statistical analysis. So now you can see the mean is nearly equal to 0. Here the mean is nearly equal to 0. The variance is 0.45. The standard deviation is 0.70. Okay. So that is the mean, variance and standard deviation of the 10 elements. Okay. So here you have created 10 elements with a rand n. So what is the mean of that? It is the mean is equal to some 0.0066. What is the variance? 0.49. What is standard deviation? 0.70. So in this way, your rand n method will be useful in creating the random data. Similarly, if you want to create a two-dimensional array with float values in the normal distribution, you can simply mention the size np dot random dot rand n. So I want to create a size of 3 by 4. I want to create an array of size 3 by 4. It has created an array of size 3 by 4. Okay, which is satisfying the normal distribution. Similarly, if you want to create a three-dimensional array, same. np dot random dot rand n. Here I have mentioned 2, 3, 4. That means I want to create a three-dimensional array of size 2, 3, 4. So it has created the three-dimensional array of size 3, 4, 2, 3, 4, which is satisfying the normal distribution. So like this, rand int, rand n, uniform, rand n are the 4 methods for generating the random data. Okay. Suppose here in the rand n, it is fixed. Here the mean is fixed and the standard deviation fixed. So if you want to customize your mean and the standard deviation, you have another method called as normal. In that normal, we can customize your mean and variance. So in the previous case, in the rand n, it is not customized, it is fixed. If you want to create your customized mean and variance, you can go with another method called as normal. Another method called as normal. In normal method, available in the rand module, so normal. In this, what we are doing, we can customize. Customize means you can create your own. Customize mean and variance. You can customize your mean and variance. So that is the use of normal method. So what we do with normal method? Suppose if you use np dot random dot normal. If you execute this, it generates a value. Suppose if you want to give a customized values, suppose np dot random dot normal. Suppose I am customizing the mean as 4, mean as 10 and deviation as 4. Here I am mentioning the size is equal to, I want to create 10 elements. So now you can see it has created 10 elements by satisfying the mean and variance. Suppose if you want to see the mean and the variance, you can print like this. Print mean is suppose here I am showing the value in A. Here I am showing the value in A. Now I want to see the mean. So A dot mean. And also I want to see the variance. I want to see the variance. Variance A dot var. Now I want to see the standard deviation. Here the standard deviation A dot std. Now if you print, so you can see the mean is 9.17, the variance is 26 and the standard deviation is 5. So it is given, you can see like this, the mean, variance and standard deviation from the given normal method. Similarly, you can create an array of any size. Suppose np dot random dot normal 10, 4, here I am writing the size. Here I am writing the size as 3 comma 4, 3 comma 4. Now I am printing B. Now you can see it has created an array of 2-dimensional with size 3 by 4 in which all the elements are float type, which is satisfying the given customized mean and the variance. Okay. And the last method in the random module is shuffle. So what the purpose of shuffle is? It modifies a sequence in place by shuffling its contents. Suppose if you have an array, one-dimensional array, you want to shuffle the elements along the x-axis. That means x is equal to 0. So it will shuffle the elements. That means it is also you cannot expect it will shuffle all the elements in different way. So like random numbers generation, shuffling also a randomized method in which you are shuffling the elements from in different shapes. Suppose this function only shuffles the array along the first axis of a multi-dimensional array. If it is a single dimensional array, all the elements will be shuffled in a x is equal to 0. Even if it is a multi-dimensional array, all the elements will be shuffled along the first axis of the multi-dimensional array. So if it first axis means if it is an x-axis, in along the x-axis, all the elements will be shuffled. The order of sub-arrays is changed, but their content remains same. Suppose if you want to, suppose here I am creating an array A is equal to np dot a range of 9. So how many elements are there? It creates 10 elements. If you want 0 to 8, suppose if you see it is created 0 element. Now I want to shuffle the values of A. So np dot where the shuffle method is available in the random module. So np dot random dot shuffle, np dot random dot shuffle, and you pass the array. Now if you want to print the values of the array, now you can see initially the values are these 0 1 2 3 0 1 to 8, but now the values are shuffled. Now 6 came here, 7 came here, 1 came here, and that means the values are shuffled. Okay, along the x is equal to 0. So not only one dimensional, you can create any dimension and you can shuffle. Suppose here I am taking A is equal to let us suppose np dot random dot rand int. I want to create random numbers in between 1 to 100. Here I have given the size is equal to some 5 by 6. Now if you want to print A, so you can see it has created an array of random integers in the given range from 1 to 101. That means 1 is included and 101 is excluded. So 1 to 101, it has created an array of size 2-dimensional with random integers. Now I want to apply the shuffle method. Suppose if you apply np dot, the shuffle method is available in random module shuffle, and I am passing my array. Now you can see now I am printing print A. So after shuffling the array A, you can see the elements are like this. So how the shuffling happened here? Shuffling happened along the axis. Along this axis is equal to 0. Shuffled. That means here the row 9 comes here. The remaining elements place are same. Here the 12 comes to the second place. The same. Here 41 comes to this row comes to the first place. This row goes to the third place. This row remains as it is. So along the axis is equal to 0. along the axis is equal to 0. This shuffling happened along the axis is equal to 0. That means these rows are shuffled. These rows are shuffled, not the element wise shuffling. Rows are shuffled. Okay. So this is the meaning of shuffling method. And also you can apply the shuffle method in a 3-dimensional also. Okay. So finally, in this entire video, I have explained the various methods available in the NumPy random module. So finally, here I am giving the summary of random library functions. So first one we have learnt is random int. So what is the purpose of random int? To generate random int values in the given range. That means you can customize the range, and in the customize range in the given size, the random numbers will be generated. Either you can generate a 1-dimensional, 2-dimensional, 3-dimensional, or any dimension. The second one is rand, to generate uniform distributed float values in the given range 0 to 1. If in the rand it will generate always integer values. In the rand it will always generate float values in between 0 to 1. And also we can customize the range using the uniform method to generate uniform distributed float values in the given range from low to high. Here low is included and high is excluded. And another method is randn. So what is the purpose of randn? It creates a normal distributed float values with the mean 0 and standard deviation 1. That means always the mean is 0, the standard deviation is 1. But in normal, if you want to customize your own mean and standard deviation, you have to go with the method normal. In the normal method, normal distributed float values with specified mean and standard deviation will be standard with a specified mean and standard deviation. You can give whatever the mean you want to give, you can give whatever the standard deviation you want to give, you can. In that range, it will create the arrays. And finally, the last method is shuffle. To shuffle the order of elements in the given array, you can use the shuffle method. So these are the 6 methods available, which are very important when you are creating NumPy arrays, when you are dealing with probability statistics, when you want to deal with the data analysis. You need these random module functions. Okay, please go through the video and please practice while you are listening the video, or after listening the video you just practice so that you will get hands-on knowledge. So listening is not only sufficient, along with the listening you have to practice so that you will get more knowledge and more hands-on experience. Okay, so in the later classes I will explain the remaining parts of the NumPy. Thank you one and all. Please subscribe to my YouTube channel Learn with Lakhneni. Please don't forget to subscribe our YouTube channel Learn with Lakhneni. So soon we are going to launch pandas videos, and also we will start matplotlib, and also we will start the machine learning concepts. So please subscribe to our channel so that you will get all the alerts and notifications from our channel of all updated videos. Thank you one and all. Stay tuned to Learn with Lakhneni.